Okay, so for this question, we have a diagram and there's a map of the Singapore, and they actually use a Cartesian XY axis coordinate system to show this map. And actually we are also given the coordinates of the Singapore Zoo, which is 8.5277, and also the coordinates of Jurong Bird Park, which is 5.3. Find the length of the line segment joining these two places on the coordinate system, on the coordinate plane. Since we have the coordinates, simply apply the formula for length, which is the square root of y1 minus y2 bracket square plus x1 minus x2 bracket square. Do take note the square root sign must cover the whole thing, and just substitute the values in. y1 minus y2, so it's 7.7 minus 3 bracket square plus x1 8.5 minus x2 5 bracket square. And therefore, if I use my calculator, this would give me, let's see, what value would that give me? Okay, this will actually give me square root of 34.34, and therefore final answer square root of this would be 5.86 units to 3 significant figure. Now, part B, we are supposed to find the shortest distance between these two places if 1 unit represents 2 kilometers. If you realize, this line represents the most direct route from the bird park to the zoo, and therefore this represents the shortest distance. So for part B, it is simply, since 1 unit is 2 kilometers, I have this particular 5.86 units, but I wouldn't want to use this. This is to 3 significant figure, so this I will actually use the square root of 34.34. And since 1 unit represents 2 kilometers, how much is this unit? Very good. So therefore the shortest distance is simply the square root of 34.34 times 2 kilometers, and that will give me 11.720068. Final answer 11.7 kilometers to 3 significant figures. Okay, so for this question, we are given a diagram. That's nice of them. P, Q, R. P and Q, the coordinates are given. So we are supposed to, for part A, find the length of PQ. So part A, please recall the formula for length of P, or for length of a segment, will be y1 minus y2 bracket square plus x1 minus x2 bracket square. Do take note the presentation, make sure the square root covers the whole thing. Therefore, I would have y1 minus y2, so 2 minus 0 bracket square plus x1 minus x2, so 0 minus 0.5 bracket square. And let's see what value does this give me. So I would have square root 4.25, and therefore the final answer, square root 4.25, 2.06 units to 3 significant figure. For part B, if we look carefully, we are supposed to find the coordinates of R, and if we look carefully, this is a ladder, and what do you notice? Yep, the length is the same. So this is an isosceles triangle. That means the distance here and the distance here must be the same. And therefore, if here is 0.5 units, because the coordinate of P, x coordinate is 0.5, here must also be 0.5. So therefore, B, I can straight away write down the coordinates of R. And for part C, find the equation of QR. So now that I have the coordinates, to find equation of QR, usually we first need to have step 1, find gradient. So gradient of QR will be equals to y1 minus y2 over x1 minus x2, and once I have this, let's see what is the and I get 4. So the gradient is 4. And if you look carefully, the y-intercept is actually 2. Yep. And therefore, for the equation of QR, y equals to mx plus c, we have the gradient for x, we have the y-intercept 2, and that concludes this question. Okay, for this question, we are given a table of values, and this table of values describe a boy that runs towards a bus stop. The distance is y meter, and this distance is from the bus stop, and the time taken. Alright, so for the very first question, y against t, this will be the vertical axis and this will be the horizontal axis. And step 1 is, of course, if you're given a graph paper, that would be great. If not, well, let's do some sketching. So this will be not x, sorry, this will be t, and this will be my y. So in this case, the t will be from 0 to 8, so let's maybe from 0 to 4, 6, 8, and I would just want to extend a little bit 10, and the distance y, the highest distance will be 30, and this one will be 6, so therefore for simplicity, do you notice that, I hope you guys notice that all these are multiples of 6, so I shall do that here. 6, 12, 18, 24, 30, and my axes are done. So now it's simply to plot the points when time is 0, y is 30, t is 0, y is 30, so this point here represents 0 and 30. T is 2, y is 24, so when t is 2, y should be 24, so 4, 18, 6, when t is 6, y is 12, and 8 and 6. And so, last but not least, of course, is to join this line. And we are done with the drawing part. So, how do we describe the relationship between t and y? Well, they have a linear relationship. Since we are able to draw a linear graph between t and y. That concludes part A. For part B, now that we have the graph drawn nicely, part B is to express this particular line as an equation in the form y equals to mt plus c. If you guys notice, this is the form of y equals to mx plus c, where m and c, if you guys realize, m denotes gradient and c is the y-intercept. And from just by looking at the graph, the y-intercept is 30. So my job now is simply to find the gradient m. So how do I go about doing that? I simply make use of 2 points here. I would like to use 0, 30, and perhaps this point 8, 6, so that I got 2 points. Just apply the formula. So the gradient is equals to y1 minus y2 over x1 minus x2. The first y value 30 minus the second y value, which is 6, over the first x value 0 minus 8, and that will give me a value of -3. So once I have this, I know that this will be -3, and therefore do not leave your answer like this. The equation will be y equals to -3t plus 30. So that will be for part B. Okay, so for this particular question, part C, we are supposed to find the time when the boy reaches the bus stop, and if we look carefully, if y is the distance from the bus stop, So when at y equals to 0, boy reaches the bus stop. So all I have to do, I look and I realize I gotten the answer from the graph. Time required is 10 seconds. And that concludes part C. Okay, for part D, in this part, we are supposed to interpret the meanings of M and C. So, do you notice for C, which happens to be the y-intercept, what does this number represent? So this number represents the distance from the bus stop. But more specifically, because all this distance represents, all these numbers here represents distance from the bus stop. But what is so special about this 30? Yep, this is at time 0. Time equals to 0. That means, does the boy moved already? Yep, no. So this is the distance from the bus stop before the boy moves. And for M, well, for M, I guess we have to look at how M is being calculated. If you look carefully, for M here, I'm going to just write down here. If we look at the working carefully, the units here will be in terms of meter, the distance. And the units here is in terms of second. So what's the unit for M? What's the unit for M? Yep. The unit, oops, for M is actually meter per second. What quantity have the same unit? Yes, therefore M represents the speed of the boy. Okay, well, what are we given in this question? We now know that there's a straight line, and this straight line passes through, there's a point A and point B. A part 1, find the gradient. So, please do remember for gradient, it'll be y1 minus y2 over x1 minus x2. And this is a personal preference of mine. I would like to always write down the coordinates in this way. And therefore, this will be my x1, y1, x2, y2. And so, the gradient will be 3 minus 12, 0 minus 3 over 0 minus 3. And that will give me a value of 3. And that will be the gradient required for A part 1. And for A part 2, find the equation of this line. We have the gradient, we have the point. So all we have to do, simply substitute one of the point, I would like to choose point A because the number is smaller, and the gradient, which is equals to 3 into y minus y1 equals to m bracket x minus x1. So y minus y1, 3 equals to the gradient 3 bracket x minus 0. So y minus 3 equals to 3x. Therefore y equals to, I'm going to plus 3 on both sides, and that will give me 3x plus 3. And that's the equation of the line AB. Okay, for part B, we now know that there's a line x equals to 3, which is the axis of the symmetry, line of symmetry for triangle ABC. So to solve this in the easiest possible way, I usually like to do a sketch. So this will be my y-axis and my x-axis. So for point A, x is 0, this is the origin. Y is 3, my point A. For point B, x is 3, y is 12. So I've gotten my point B. So this one will be my line AB, and x equals to 3 happens to be my line of symmetry. That means here this will be my AB, and therefore if this happens to be my line of symmetry, that means if I reflect this over to the other side, this will be my point C. If this is a line of symmetry, it means the distance here and the distance here must be the yep, you're right, same. So if here is 3 units, here must also be, let me use blue color so that you guys can see, 3 units. That means from 3 to here, it has to be 3 plus 3, 6. So now I know the x value for C is 6. And because this has to be a line of symmetry, reflection, therefore the y value, this has to be a horizontal line, the y value is 3. Well, this is inside the diagram, so please, for your answer, please do present your answer neatly, and that will be the answer for part B. Okay, we are given this rectangle ABCD where the coordinates are given respectively here. Find the length of BC. Oh, I've given the coordinates. So for part A, which is pretty easy, so BC will be equals to, do take note of the formula, y1 minus y2 bracket square plus x1 minus x2 bracket square. Do take note, the square root must cover the whole thing. And so y1 minus y2, so that will be 9 minus 1 bracket square plus 11 minus 5 bracket square, and therefore this will be the square root of 110 units. Well, for part B, given this rectangle means that this is important. The opposite sides are parallel. Since AB parallel to CD, it means the gradient of AB must be equal to the gradient of CD. So this form the basis on how we are going to solve for value of A. So of course, let's start with gradient of AB. We are given the coordinates. So y1 minus y2, 4 minus 1 over x1 minus x2, 1 minus 5. This gives me a value of negative 3/4. And therefore we can make use of this for gradient of CD. That means for gradient of CD, A plus 5 minus 9 over A minus 11. The gradient of CD must equals to the gradient of AB, therefore is equals to negative 3/4. So let's do a simple, and we are going to simplify this. So 5 minus 9, so A minus 4 over A minus 11 equals to negative 3/4. Going to times A minus 11 times A minus 11, so that here no more. Also can times 4, so that here also must times 4, so that this one can be divided off, this one can be divided off, and we are left with 4 bracket A minus 4 equals to negative 3 bracket A minus 11. Simplify further. For A minus 16 equals to negative 3A, negative times 3, negative 3 times negative 11, positive 33, plus 3A on both sides. That will give me 4A plus 3A plus 16 on both sides. So this side will be 33 plus 16. So 7A equals to 49. Therefore, I'm going to divide by 7 on both sides. So A equals to 49 over 7. That will give me a value of 7. And once I have the value of 7 for A coordinates, therefore D will be 7, 7 plus 5, 12. For part C, the equation of the line CD from part B, we gathered that D is 7, 12. That's the coordinates. And therefore, equation, always step 1, find the gradient. So in this case, the gradient of CD, which we already have, is negative 3 over 4. So step 2, we are going to substitute one of the point. So I'm going to go with C, 11, 9. And the gradient, negative 3/4 into y minus y1 equals to m bracket x minus x1. So y minus y1 is 9 equals to m negative 3/4 times x minus 11. So y minus 9 equals to negative 3/4 x, negative 3/4 times negative 11. That will give me positive 33 over 4. And I'm going to plus 9 on both sides. So it will be y equals to negative 3/4 x plus 33 over 4 plus 9, and I'm going to continue to simplify further. So my y will be equals to negative 3/4 x plus 69 over 4, and that is the equation of the line for CD.